stability of slopes. Stability of slopes. Okay, so one of the important topic of soil mechanics, I will be discussing here some important formulas as well as concepts which will be helpful in solving numericals. Okay, so first is Taylor's stability coefficient. Now what is Taylor's stability coefficient? It is denoted by Sn. It is Sn is equal to C, that is cohesion, upon gamma FCH. Okay, so remember this, C is your cohesion, gamma we know it is unit weight of soil, FC is factor of safety, H is height. So one thing you should remember is, in case of cohesionless soil, slope angle cannot be greater than phi. Okay, so slope angle may be we can term it beta. Okay, so this is your slope angle. Suppose this is your angle, this is the slope angle, so it cannot be greater than phi. Now what is phi? Phi is angle of internal friction. Okay, so now see, factor of safety it always depends on height of soil. Height of soil in this slope. Okay, so now mathematically what do you mean by factor of safety? See, factor of safety is basically ratio of resisting moment to actuating moment. Okay, so it is a ratio. So of course it will be ratio of two moments, then only it will have no units. So factor of safety, mathematically it is CLR upon W into I can write in bracket perpendicular distance. Okay, now again we know C is the cohesion. Unit of cohesion will be kilonewton per meter square. Basically it is stress. L is the length of the arc of the slip circle. So length will be in meter. So length of the arc of the slip circle, so that is in meter. R is radius, so radius will also be in meter. Now what is W? So W is, we know density is weight upon volume. Okay, so gamma is equal to W, W is equal to gamma into area of soil within this slip circle. Let me show you on the other page. Next page. See, Suppose this is your radius r. So this is your arc. Okay, let me show you in different color. See this, I am drawing in red color. Okay, so this is the basically area of soil within the slip circle. Okay, and we have to find out this area. Okay, and when this area will be multiplied by gamma. Okay, so gamma multiplied by area of soil within the slip circle. Okay, so that will be your W. Okay, so basically now what is this area of soil within the slip circle? So mathematically it will be pi r square theta by 360 minus area of the triangle. Okay, so we will solve one question, and from that you will be able to understand. Okay, next important concept is regarding infinite slope. So for infinite slope, when seepage occurs, seepage is basically the flow of water uh, inside the ground, inside the soil. So when seepage occurs at and parallel to the slope surface, so in this case factor of safety is equal to gamma dash tan phi dash upon gamma set tan beta. Okay, now see, this formula is very important. Why it is important? See, first of all, you should remember this is a case of infinite soil, infinite slope. Now see, suppose this is your angle beta. Okay, now this is the slope of the soil. Gamma set is your saturated unit weight of soil, and gamma dash is submerged unit weight. Now we know the relationship that gamma dash is equal to gamma set minus gamma W, and we know what is gamma W. Gamma W is 9.81 kilonewton per meter cube. Okay, so here it is gamma dash tan phi dash. Now what is dash? Tan phi dash. See, whenever we are representing, suppose this is phi dash, so it is effective angle of internal friction. We all know what is effective pressure. It is total pressure minus pore water pressure, right? So beta, here beta is basically it is safe angle of slope for the soil, or we can say it is maximum slope angle. Now mathematically we know the relationship also. gamma dash is equal to gamma set minus gamma w. At the same time, gamma dash is equal to, you can remember this formula is also important, g minus 1 upon 1 plus e gamma w. Now what is g? G capital G is specific gravity of soil. And what is small e? We know it is basically Voigt's ratio. Alright, then next thing which you should remember is, see, when the canal flows, very important point, mark some 2 to 3 stars. It can be asked in MCQ, especially in engineering service exams. They are asking such type of technical questions. So when the canal flows full, the canal bank slopes will be submerged under water. Okay, so obviously when the canal is running full, the canal bank slopes will be submerged under water. It will be under the water, fully submerged. So in that case, the stability, Taylor stability coefficient Sn, so that formula will become C upon gamma dash FCH. Okay, there is nothing different, just gamma will become gamma dash, because it will represent, gamma dash is submerged unit weight. But at the same time, see the difference. When the canal has sudden drawdown of water. What do you mean by sudden drawdown of water? When the water is emptied quickly. So sudden drawdown of water, the soil remains saturated for some time. So remember this thing, that in case of sudden drawdown, when the water is completely removed, so the soil will be in saturated condition for some time. Okay, for some time. So in that case, the stability coefficient Sn will be C upon gamma set FCH. Okay, so see the difference. If they are asking that canal is running full, then you have to take gamma dash, and if they are saying that the canal has sudden drawdown, then you have to take the value of gamma set. Okay, so basically the formula is same, but you should know where which quantity we have to use. Okay. Now another important point, I am writing on next page. For infinite soil slope, the factor of safety with respect to everything I am writing in short form, shear strength. Okay, so mathematically factor of safety is equal to tau f upon tau. Tau is the shear strength, so we know tau f is C plus sigma tan phi. So here I am writing C dash plus sigma dash tan phi dash. Everything will be in the effective category. Okay, so now the shear strength mobilized. Shear strength mobilized means, what do you mean by shear strength mobilized? Shear strength basically collected. Okay, in books you will find this term shear strength mobilized. So mobilized is basically collecting all the shear strength of the soil. Okay. So whenever some exam is coming, then we are collecting all the study material. So we are mobilizing the study material, and after that we are starting preparation. So here also, whenever some load is coming, so soil will mobilize all the shear strength. Okay, so shear strength is getting mobilized. Basically, it is collecting the total shear strength. Okay, so tau is equal to C dash upon factor of safety plus sigma n dash 10 phi dash divided by factor of safety. So here basically when you are dividing by factor of safety, it will become mobilized. So Cm plus sigma n dash 10 phi m dash. So can I write 10 phi m dash is equal to 10 phi dash upon factor of safety? Mobilize means collecting. Okay. So remember one thing, factor of safety in submerged condition is more than that in saturated condition. So basically factor of safety is equal to gamma dash 10 phi divided by gamma sat 10 beta. Okay, so same formula. This formula, if we are talking in for dry or submerged slopes, then factor of safety will be just a ratio of 10 phi to 10 beta. Okay, so remember this thing. Suppose they are telling that there is a dry condition or submerged slope, so both will be having same formula of factor of safety, that is factor of safety is equal to 10 phi upon 10 beta. So what can we conclude from this? We can conclude, I am writing in note. Okay, so just you can also note there is a difference between submerged condition and saturated condition. Okay, obviously there is difference between submerged condition and saturated condition. Saturated means all the pores are filled with water, and submerged means it is totally underwater. Okay, so basic difference is saturated condition means all the pores are filled with water, there are no voids, totally all the voids are completely saturated with water, and submerged means it is actually under the water. So in submerged condition, seepage does not take place through the soil parallel to slope. Okay, so what happens? Hence, in calculation of factor of safety, both in numerator and denominator. We use gamma submerged, okay, or gamma dash, okay, because see, in submerged condition both will be submerged, gamma set will be equal to gamma submerged only, okay. So ultimately it will cancel out from numerator as well as denominator. But when soil is in saturated condition, seepage takes place and water table is assumed to be parallel to the slope. Now see, we are talking about saturated conditions, okay. So remember this point is very important. So when the soil is in saturated condition, seepage takes place and water table is assumed to be parallel to the slope, okay. So in that case, let me write the formula of factor of safety. So here remember gamma dash upon gamma set. Now see, it is gamma dash upon gamma set cos square beta tan phi cos beta sin beta okay. Let us solve one small example so that you will be able to understand. Suppose calculate factor of safety of an infinite soil. The data given is C is equal to 0, phi is equal to 35 degree. Phi is your angle of internal friction, right? So this is your angle of internal friction. Gamma D is 16 kilonewton per meter cube. Gamma D, what is gamma D? Dry unit weight. Okay, so gamma D they have given. Gamma set, we know saturated unit weight, so obviously it will be more than gamma D, that is 20 kilonewton per meter cube. Now we have to find out the factor of safety. So suppose this is the given data, okay, and they have given one figure also. See, this is your slope, ground slope. So angle beta, this will be your angle beta, that is 30 degree. This is your actual soil and this is your, suppose, groundwater table. So the groundwater table is 2 meter below the ground level, and this is your slope hard strata, which is 8 meter below it. Okay, so total will be your 10 meter, right? So in this case, first of all, we are supposed to find out gamma dash, and we know the formula gamma dash is gamma set minus gamma w. So that is 20 minus, suppose the data given here is gamma w is 10 kilonewton per meter cube, it is given here, okay, or else we can take 9.81 kilonewton per meter cube also, but here it is given. So to make the calculation easy, 20 minus 10 is equal to 10 kilonewton per meter cube. So factor of safety is equal to 1 minus gamma WH divided by gamma set Z into tan phi upon tan beta. Just put all the values in it and you will get the answer. So 1 minus 10, height is 8, then gamma set we know it is 20, this is 10, Z means total, okay, 10 phi, your phi value given 35 degree, right, and tan beta is your 30 ground slope. So work out factor of safety, you will get the answer 0.73. This is your factor of safety. So here you have to see that Z is your total height, that is 10 meter, and H is 8 meter, that is the groundwater table height from the rock solid bottom. Okay, let us solve one similar question which has been asked in GATE exams. So the soil profile given below is having infinite slope. Okay, so they have given directly the figure like this. This is your angle. Now obviously this angle is your beta 25 degree, and this is your rock surface. Basically this is rock surface. Now here, see, to make the things complicated, they have given two soils. So one is both the soils are having same height, 5 meter 5 meter. This is one and this is second layer. I can say soil A and one is soil B. Okay, let me write the soil A parameters here. Soil A is having gamma is equal to 16 kilonewton per meter cube, and they have given SU. SU is undrained shear stress. Undrained shear stress. It is 40 kilonewton per meter square. Same way for soil B, they have given the value of gamma is equal to 20 kilonewton per meter cube, and SU is equal to 60 kilonewton per meter square. Now we are supposed to find what we are supposed to find the slip will occur at a depth of dash, so dash meter. Okay, basically we are supposed to find the depth of the slip. So when this condition will occur, so first of all we have to ask question to ourselves that the slip will occur. So when will it occur? Basically the slip will occur, let me write here, the slip will occur when shear stress, when shear stress is greater than or equal to shear strength. Obviously, if shear stress is greater than the shear strength, then there will be slip. So in this case, technically tau is greater than or equal to SU, under shear stress. So gamma 1 Z1 plus gamma 2 Z2 sin beta cos beta greater than or equal to SU. Okay, just substitute the values. So here you can see our first layer, its thickness is 5 meter. Okay, but Z2 we have to find, because that is actually the slip, depth of the slip. So here I am substituting the values. 16 gamma gamma 1 means for soil A, so 16 into 5 plus 20 Z2. Now see, sin beta cos beta, I know the formula of sin 2 theta. Sin 2 theta is 2 sin theta cos theta. So basically I can write sin 2 beta divided by 2 greater than or equal to, now here the SU should be greater than or equal to 60. Now beta is equal to 25 degree. So 80 plus 20 Z2 sin 50 degree divided by 2 greater than or equal to 60. So what will be the Z2? Z2 will be, calculate, it will come out to be Z2 is equal to 3.83 meter. 3.83 meter means, now this is just Z2, but actually we have to find the depth of slip. So depth of slip is equal to the top 5 meter plus this Z2, 3.83. So it will be, your final answer is 8.83 meter. Okay, so don't conclude your answer with 3.83, it will be wrong. They have asked you depth of slip. So depth of slip means basically you have to add this 5 meter of soil A plus 3.83 meter of soil B. So when you add both these things, you will get the final answer 8.83 meter. Okay, now one concept we will study in friction circle method of slope analysis. Remember this point, it is very important. If small r, okay, I will show you by drawing, but first you write this. If small r defines the radius of the slip circle, the radius of friction circle is dash. Okay, so just concentrate over here. See, this is your point ABCD. Suppose this is your point so this is your slip circle. Okay, this is your slip circle, and this is your friction circle. See this. So this is your friction circle. Now small r means this slip circle radius. This is your small r. So they have asked friction circle radius. So friction circle radius r dash is equal to r sine phi. Okay, remember this thing. It is r sine phi dash, basically phi dash. Okay, so for infinite slope of C5 soil means it is having both the cohesion as well as angle of internal friction. So in this case, to maintain limiting equilibrium, factor of safety is equal to C upon gamma h sin beta cos beta plus tan phi upon tan beta greater than or equal to 1. So suppose they have given infinite sand slope. Okay, so this also you remember, for infinite sand slope. See, whole chapter I will be covering in my YouTube videos of you can see the playlist of Geotechnical Engineering. So in that I will be covering the whole chapter, but at present you may get the feeling that I am skipping some of the things. But why I am skipping some of the things? Because they are actually not that important. Whatever is important from GATE point of view or engineering service exam, I am covering right now. Okay, so detailed video, if you want to see, you can check out my other videos. Okay, so here I am quickly completing the topics which I am, all the concepts and formulas I am covering. Okay, so groundwater table coincides with the ground surface. So factor of safety is equal to, in this you have to use this formula, gamma dash upon gamma set multiply by tan phi dash upon tan beta. Okay, so where is this condition? Seepage at ground level. Remember this thing. Okay, seepage at ground level. So it is gamma dash upon gamma set into tan phi dash upon tan beta. So when groundwater table coincides with the ground surface, as slope is on the verge of sliding failure, remember this formula, slope is on the verge of sliding failure. Verge of sliding failure means it's just about to fail. Okay, at any moment of time it will fail. Okay, at any moment of time it will fail. So in that case, obviously factor of safety will be equal to 1, that is gamma dash upon gamma set into tan phi dash upon tan beta. This value will be 1. Okay, so factor of safety is 1 when the slope is just about to fail. Okay, this is very important point. Okay, mark it 5 star. So thank you very much